On a Friday morning sometime around 8 o'clock, an engineer at NASA's Jet Propulsion Laboratory is going to type out a short message and send it into the dark. Nothing dramatic. Just a routine check-in, the kind of thing this team has done thousands of times since 1977. But this time, something is going to be different. That signal is going to travel for 24 straight hours before it even reaches its destination. And the answer, if one comes back at all, won't arrive until Wednesday morning. Not because anything is broken, not because of some malfunction. Because the spacecraft on the other end of that conversation is now so far from Earth that light itself, the fastest thing in the entire universe, needs a full day just to cross the distance between us. This is a spacecraft that was built using 1970s technology, designed to last 5 years, and running today on less power than your kitchen light bulb. And right now, in 2026, NASA is still receiving signals from it, still getting real information back from farther away than any human-made object has ever managed to transmit from. Stay with me, because the story of what this machine is still doing out there, this far from home, is honestly one of the most remarkable things happening in space right now, and almost nobody is talking about it. Subscribe now if you want. More stories like this, because we are just getting started. And let's talk about exactly how far away we're actually talking about, because the number itself is difficult to hold in your head without some kind of comparison. Voyager 1 launched from Kennedy Space Center on September 5th, 1977, on a mission that was supposed to be simple. Fly past Jupiter, fly past Saturn, take some photographs, collect some measurements, and then quietly power down sometime around 1981 or 1982. Instead, it kept going. It used the gravity of each planet like a slingshot, picking up speed and distance with every flyby, and it simply never stopped. Today, in 2026, Voyager 1 sits somewhere around 16.1 billion miles from Earth, roughly 25.9 billion kilometers out, traveling in a straight line at 38,000 miles per hour. A speed and trajectory it has held steady since its final planetary flyby past Saturn back in November of 1980. Here's the number that actually captures what that distance means in practical terms. A radio signal, traveling at the speed of light, the fastest anything in the universe can move, currently takes more than 23 hours to cross the gap between Voyager 1 and the ground stations tracking it here on Earth. Not minutes, not a couple of hours. Nearly a full day, one direction. And that number is still climbing. According to NASA's own projections, on November 18th, 2026, Voyager 1 will cross a threshold no human-made object has ever reached before. It will become exactly one light day from Earth. At that point, a signal moving at the absolute maximum speed the laws of physics allow will take a full 24 hours just to arrive. Susie Dodd, the Voyager project manager at NASA's Jet Propulsion Laboratory, put it about as plainly as it can be put. If her team sends a command and says good morning to Voyager 1 at 8 in the morning on a Monday, they will not hear the spacecraft's response until roughly 8 in the morning on Wednesday. 2 full days, round trip, for a single exchange. Think about what that actually means for the people running this mission day to day. There is no such thing as a real-time conversation with Voyager 1 anymore. Every single command the team sends has to be complete, correct, and final before it's transmitted, because there is no quick follow-up, no immediate correction. If something goes wrong, you send the instruction into the dark, and then you wait 2 full days to find out what happened. Now here's the part of this story that should genuinely stop you for a second. Nothing about this was supposed to be possible. When Voyager 1 launched in 1977, NASA's own engineers gave it a projected lifespan of somewhere between 4 and 5 years. The mission plan didn't even seriously account for a scenario where the spacecraft would still be operational, let alone still returning usable scientific data, nearly half a century later, at a distance that puts it a full day's journey away from Earth at the speed of light. This is a machine built with the technology of the disco era. It launched the same year the very first Star Wars film hit theaters, before the personal computer had even become a household object, using hardware with millions of times less memory and computing power than the phone sitting in your pocket right now. And it is still talking to us. Let's get into how that's even physically possible, because the engineering reality behind this mission is honestly more remarkable than most people realize. Voyager 1 gets its electricity from 3 radioisotope thermoelectric generators, essentially containers of plutonium-238 that produce heat as the radioactive material slowly decays, with that heat converted directly into usable electrical power. At launch, back in 1977, those generators produced around 470 watts, enough to comfortably run all 11 of the spacecraft's original scientific instruments at once. Today, after nearly 50 years of continuous radioactive decay, that output has dropped to somewhere around 250 watts, and it keeps falling by roughly 4 watts every single year. It is, quite literally, a slowly dying battery, sitting 16 billion miles from the nearest possible repair technician. Of the 11 scientific instruments Voyager 1 originally carried into space, only 4 are still operating today. Every single shutdown decision along the way has been a genuine trade-off, weighed carefully by the team at JPL. Turning off a heater might free up a few precious watts of power, but it also risks letting some critical, irreplaceable component freeze solid in the ambient temperature of interstellar space, which sits at roughly minus 270 degrees Celsius, barely above absolute zero. Since the late 1990s, the ground team has been progressively and deliberately powering down non-essential systems, one careful decision at a time, purely to buy this aging spacecraft more years, more months, sometimes just more weeks of continued operation. And yet, through all of that, through the failing power, through the instruments going dark one by one, through distances that were never part of the original engineering plan, Voyager 1 keeps sending something back. That, right there, is the actual headline. Not a single dramatic signal, not one shocking transmission. The genuinely unexpected thing happening right now, in 2026, is that this spacecraft is talking to us at all, from a distance this extreme, using power this limited, on hardware this old. Nobody who designed this mission in the 1970s expected this conversation to still be happening. And it is. It's worth understanding exactly what kind of information is even coming back at this point, because the fact that any coherent data makes the journey at all is itself worth appreciating. Voyager 1 crossed the heliopause, the outer boundary of our solar system, back in 2012, becoming the first human-made object to physically enter interstellar space, the region beyond the protective bubble of the sun's solar wind. Everything it has sent back since then has been humanity's only direct, real-time window into that environment, a region no other instrument in history has ever been able to sample from the inside. And what it found out there wasn't the calm, largely empty void that decades of theoretical models had predicted. Starting in 2017, Voyager 1's plasma wave instrument began detecting a persistent, unexplained emission in the surrounding interstellar plasma, evidence that the space between stars is far more turbulent, more structured, and more active than any model built from Earth had ever suggested. That data is still trickling in today, carried across a distance that keeps growing by roughly 38,000 miles every single hour, on a signal so faint by the time it reaches Earth that it has to be captured by the massive dish antennas of NASA's Deep Space Network, then amplified and reconstructed before anyone can actually read it. Here's a detail that puts the sheer fragility of this whole operation into perspective. Back in 2023, Voyager 1 very nearly went silent for good. A single degraded memory chip, one small physical component that had slowly deteriorated after decades of exposure to cosmic radiation, began corrupting the portion of the spacecraft's software responsible for formatting and transmitting its data. For 5 months, the signal kept arriving, but it was unreadable, scrambled, essentially gibberish. Engineers at JPL spent those months painstakingly diagnosing and repairing the problem entirely remotely, with each single test cycle requiring a minimum of 44 hours round trip, just to send an instruction and receive the result. It was, in effect, remote surgery performed across 16 billion miles of empty space on a patient nobody could physically reach. And it worked. By mid-2024, Voyager 1 was back online, transmitting clean data again, as if daring anyone to count it out for good. That history matters here, because it's the exact same spacecraft, the exact same fragile, aging, precariously balanced system that is now closing in on the one light day milestone this coming November. And the team managing it isn't just watching the countdown happen passively. They're actively working to keep it going as long as physically possible. Engineers have reportedly been testing an experimental power redistribution procedure, first trialed on Voyager 1's twin spacecraft, Voyager 2, aimed at squeezing additional usable electricity out of systems that are currently running less efficiently than they technically could be. If that procedure proves successful and safe, there's a real, if cautious, possibility that it gets applied to Voyager 1 as well, potentially even allowing a previously shut down instrument to come back online. Nothing is guaranteed, but this team has spent decades proving that betting against this spacecraft is usually a losing bet. Dot and her team have said plainly that their goal right now is getting both Voyager probes to their 50th anniversary of launch, which for Voyager 1 falls in September of 2027. Given everything working against that goal, the failing power supply, the growing communication delay, the sheer physical distance now separating this machine from the only species capable of understanding what it's sending back, reaching that milestone would be nothing short of remarkable. So here's where things actually stand, right now, heading toward that light day threshold in November. Voyager 1 is still out there, still moving, still transmitting, even as its signal takes longer to arrive with every single day that passes. It carries with it the golden record, a message bolted to its frame containing greetings in 55 human languages, the sounds of Earth, and a map showing exactly where our planet sits in the galaxy. in case anything or anyone out there ever finds it long after we're gone. Right now, the only thing standing between us and losing contact with the most distant object humanity has ever built is a slowly draining nuclear battery and the ingenuity of a small team of engineers who have spent decades finding new ways to keep an old machine talking. When that final signal eventually does arrive and go quiet for good, whether that's next year or a decade from now, it will mark the end of the only real-time conversation our species has ever had with the space between the stars. But that day hasn't come yet. Right now, in 2026, a machine older than most of the people reading this is still out there, still working, still finding a way to reach back across a gap that keeps getting harder to cross with every single hour. And it is going to keep doing it for as long as physics and a dying battery will allow. If stories like this, the ones tracking real missions as they actually unfold, are what you come here for, subscribe and turn on notifications, because we're going to be covering that light day milestone live in November when it actually happens. Drop a comment and let me know what you think Voyager 1 will find next, and share this with someone who needs a reminder that humanity's reach is a lot further than most people realize.